Hello, welcome. Before we get started, I just want to remind you that this is obviously a video. You can pause it, rewind it, go through it at whatever pace works best for you. This is lesson one, solving quadratics by factoring. Even though this is a video, I definitely recommend taking notes on it and doing the problems. I even recommend, if you're comfortable with it, to pause the video before I go through the problems so that you can kind of practice on your own and then use the video responses as a check. Okay, so up at the top, factoring difference of squares. So a difference of squares is, a difference of squares is one perfect square minus another perfect square, which perfect squares are like numbers that you get from squaring other numbers. So like 16, because that's 4 squared, or like 25, because that's 5 squared, or 36 even. And they don't have to be numbers, they can also be a like variable. So like x squared is considered a perfect square. Let's say 4x squared is considered one, but it is important that the 4 is also a perfect square, and we'll talk about that in a little bit. So perfects or difference of squares are also always a binomial, which is just two terms, and it's always subtraction. That's what difference means, is subtraction. So a couple of examples of difference of squares problems are here. So we have x squared minus 16. So like x squared is a perfect square, minus difference 16, another perfect square. And then 9x squared, 9 is perfect square, so is x squared, minus difference, all good. Another perfect square, 25. There is a pattern that we can use in order to factor a difference of squares. So one perfect square minus another, a squared minus b squared, and it factors into a plus b times a minus b. You may remember it a little bit from Algebra 1. If you don't worry, we're going to go through it. But just kind of note that's your pattern. I would square it, highlight it, whatever you need to on your notes so you can go back and find it. So our first problem is x squared minus 25. And you may want to do this starting off. You may not need to. It's entirely up to you. But I'm going to rewrite 25 as 5 squared. So x squared, and then instead of minus 25, I'm going to write it as 5 squared. And then now this looks like identical to this pattern. It just has actual numbers where the a and b are. So a is always the first part, that's the x, and then b is always the second part, that is the 5. So my a is x, my b is 5, and I just get to plug those in exactly for a and b. So x's will go there in the pattern, and then 5's will go in where the b is, and I just keep these signs the same. So my pattern has parentheses. It's going to be a plus b, which is x plus 5, and then a minus b, which is x minus 5. And then final answer, x plus 5 times x minus 5, and you can always check it by foiling. I'm just going to review that one time, but I won't do it every time, just to kind of keep the notes like relatively short for you guys. So foiling, remember you're multiplying everything together, so it'd be x times x, which is x squared, x times negative 5, which is a negative 5x, 5 times x, so a positive 5x, and then 5 times negative 5, which is negative 25. And then this positive 5x and this, the negative 5x and the positive 5x, those cancel each other out. So I'm left with just x squared minus 25, which that was my original problem. So my check worked. And you can always check your factoring by just foiling it back and seeing that you got to your original problem. I'm just going to erase this though so it doesn't stay too cluttered. It's a little bit easier to follow. Feel free to go back and watch it again though. Okay, so the next problem is 4x squared minus 49 right here. So as it's written right now, this exponent technically only belongs to the x. So like the 4 is not being squared, only the x is, because there's no parentheses. In order for the 4 to be squared, the problem would have to be written like that. So I can't just say a equals 4x because the 4 is not being squared. I actually have to rewrite it as like what entire quantity is being squared in order to simplify to this. So I know that 4 is 2 squared. I'm going to zoom in a little bit. 4 is 2 squared, and x squared is x being squared. So I'm going to rewrite it as 2x squared, because that means that this whole thing is being squared, which the 2 squared would become 4, and the x squared would become x squared. And then minus 49, which I know is 7, oops, not that, minus 49, which I know is 7 squared. So now I can more easily see like what my a is, that's the first part, what my b is, that's the second part, and I just got to plug it into this formula. So a plus b is 2x plus 7, and then a minus b is 2x minus 7. Sorry, that 7 got a little crazy. Still kind of crazy, but you can hear my voice, so you know it's a 7. And then the last one, x squared minus 100. This is definitely one where I recommend pausing the video and just making sure that you're able to do it on your own. If you still would like to see another example, just feel free to watch it through, but this is a good test. So I have x squared, which I'm going to leave alone because I have no number in front of it, and then I'm going to rewrite 100 as 10 squared. And if you want to skip the rewriting part, it's totally fine, I get it. Now I can see what my a and b are. So a is x and b is 10. So it's going to be a plus b, which is x plus 10. And then a minus b, which is x minus 10. So x plus 10 times x minus 10. And then remember, you can check all of these by foiling. Okay, so factoring trinomials. So just a reminder, the standard form of a quadratic is ax squared plus bx plus c. So I'm going to be using I'm going to be saying a, b, and c a lot. So we just want to remember a is always the number that's in front of x squared, and b is always the number that's in front of x. They're called coefficients. I'm going to write it in case it's helpful. Coefficients. Those are just the number that are being like multiplied out in front of the variable. So a and b are both coefficients, and then c is what's called a constant, and that's a number that doesn't have a variable. Okay, I'm gonna fix this arrow because it kind of looks like it's coming from the other part. Okay, so we're gonna start on the left side, and we'll do those first, and then we'll move on to the right side. So it says factoring a trinomial when a equals 1, you need numbers that multiply to c and add up to b. So going back to that a, b, and c basically. So I'm just going to go through and label each different part. So in this case, I know it doesn't ask for a, but if you don't see a number in front of a variable, the coefficient is 1. So a would be 1. I don't have a negative in front of, or I don't have a 1, sorry, I don't have a number in front of the x, but there is a negative there. So b would be negative 1. And then c would be negative 56. So the whatever symbol like plus or minus is in front of a number belongs to that number. So it says we need numbers that multiply to c, which is negative 56, and then add up to b, which is negative 1. So if they're multiplying to a negative number, one would have to be positive and one would have to be negative, right? So if we did a negative times a negative, that would become positive. So I'm just going to list some of the factors of 56. Probably the first one that comes to mind is going to be the one that we use. But don't forget, you can always do like 1 times the number, 2 times 28. And you don't have to list them all out. You can stop when you get the correct one, but just as a review of how to find the factors. So 56 I know is like 7 times 8. And then because I am multiplying to a negative 56, I have to make one of my numbers negative. So to get them to add up to negative 1, I'm going to make the 8 negative, and then this combination will work. And there should only be one combination that satisfies both. So like 7 times negative 8 is negative 56, and then 7 plus negative 8 is negative 1. If they add up to a negative number, the bigger number would need to be negative. So that's why our 8 was negative. So then when a is 1, like the second that we're working now, whenever a is 1, when you factor it, this first x squared is just going to break down into x and x. You don't have to worry about what number you're putting in front of it. It's always going to be x times x, because if you were to FOIL it, x times x is just 1x squared. I don't want any coefficients. And then the numbers that we found that like multiplied to negative 56 and added up to negative 1 are what fill in the rest of the parentheses. So minus 56, and then, oh, not minus 56, sorry, they were not the correct numbers. Our numbers were 7 and negative 8. So it'll be minus 8 and then plus 7. And then remember, you can always check by FOILing, so I'll check this one as well. X times x is x squared. X times 7 is 7x. Negative 8 times x is negative 8x, and then negative 8 times 7 is negative 56. And then I just need to combine like terms, my 7x and my negative 8x. So I bring down my x squared. 7x minus 8x is minus 1x, and then minus 56, which is my original problem, so my check worked. So just don't forget that you can always check by FOILing. Okay, I'm going to erase some of this clutter. Feel free to go back and rewatch that part if you need to. So final answer is x minus 8 times x plus 7. Okay, for this next one, we're going to go down a box to where it says practice. This will be a good one to kind of practice on your own first. But my A is 1, my B is negative 10, my C is 24. So this applies to like when A equals 1, there is like a different case of problems, but A is 1, so we can follow these rules. So I need numbers that multiply to C, which is C is 24, and then add up to B, which B is negative 10. So multiply to 24, add up to negative 10. So for multiplying to 24, we can say like 3 times 8, that's not going to add up to 10. And then we can say 4 times 6 or 2 times 12. And then in this case, they're multiplying to a positive 24. So both numbers would have to be the same sign. They would either have to be positive, positive, or negative, negative to multiply to a positive number. So if they both have to be the same symbol, then I have to use the 4 and the 6 and make them both negative in order to add up to negative 10. So once I have my numbers, then it's pretty straightforward. I set up my two parentheses. And since A was 1, I just have to do X and X. And then the numbers that I picked that multiplied to C and add up to B fill in the rest of the parentheses. So minus 4 right here, minus 6. And it doesn't matter which one you put where, it can switch like here to here. So X minus 4 times X minus 6. And then the next section, we're going to go to the right. So factoring a trinomial when A is not 1. So when the number in front basically isn't 1, it does get a little bit more complex, but the gist is the same. So it says that we need numbers that multiply to A times C, so not just C anymore, and then add up to B. So just to compare the two, the first type we did was they just had to multiply it to C, and that was when A was 1. Over here, they have to multiply to A times C. That's when A is not 1. So definitely like have that in your notes so that you can tell between the two types of problems. And then they both need to add up to B. Either way, that stays the same. Okay, so A is 3, so we got to use this way. B is negative 8, C is 4. So first I'm going to do A times C, which is 3 times 4, so that is 12. And then B is negative 8. So I need numbers that multiply to 12 but add up to negative 8. So off the top of my head, for multiplying to 12, they would have to be both positive or both negative since they're multiplying to a positive number. So I can use 4 and not 4. So, why am I blanking? I can use 6 and 2. Sometimes the easiest multiplication is the toughest thing to do. So I can use 6 and 2. Those would add up to 8. And then to get them to add up to negative 8, I would just have to make them both negative. So like negative 6 times negative 2 is positive 12. And then negative 6 plus negative 2 is negative 8. Okay, so now we're going to take those and we're actually going to use them to break down this negative 8x. So the first term is going to stay the same. That's going to be 3x squared. And then this order of this next part doesn't matter. So instead of negative 8x, I'm going to break it down to negative 6x minus 2. So from here to here, I didn't change the value of that term. I just broke it into two separate terms based on what I did on the right side. And it'll always be related to those numbers that we found that multiplied to a times c and added up to b. And then I just need to bring down this plus 4 now. So everything in the problem is staying the same. It's just this middle term that's getting broken up. The other two parts stay the same. So 3x squared and 4. And then now I'm going to do something called factor by grouping, where I break the expression in half, like right down the middle. And then I factor out the GCF, the greatest common factor of each half. So that's like basically the biggest number that divides, or biggest term that divides into both. So for the left side first, I have a 3x squared and a 6x. So I can divide those both by 3, so I'm going to pull that out. And then they both have at least x to the first power, so I'm going to pull that out. And then as far as the variables, you can only pull out the lower power. So I can't pull out x squared, I can only pull out x. And then factoring the GCF is kind of like doing the reverse of distributing. So, or we can actually use like distributing to figure out what we would have left inside the parentheses. So if I'm doing the reverse, I'm going to kind of work backwards. So I could think, okay, 3x times what would bring me back to 3x squared? I would need to multiply by another x. And then 3x times what would go right here that would bring me back to that net minus 6x, I would have to multiply it by a negative 2. And you can always kind of check by like distributing in your head to go backwards. So 3x squared, 3x times x, that would become 3x squared. And 3x times negative 2, that would become minus 6x. So we're all good. And then we're just going to repeat that process with the second half of the expression. So now that negative 2x plus 4, I can pull out the GCF, which if the number in front is negative, most of the time you're going to factor out a negative as well. So that 2 is negative, so I'm going to factor out a negative 2 as my GCF. I'm just dividing it out basically. So if I divide my negative 2x by 2, it's going to leave me, or by negative 2, it's going to leave me with x. And then if I divide that 4 by negative 2, it's going to leave me with minus 2. And you hopefully notice that what we ended up with in the parentheses is the same, x minus 2 and x minus 2. So now we're going to pull that out of each. So we basically created two terms here. So this is 1 and then 2 terms, and then they each have a common factor of x minus 2. So I'm going to pull that out. And then my remaining factor is going to be the part that I had in front. So 3x minus 2 is going to be what goes inside the second parentheses. So 3x minus 2. And the order that you put your parentheses doesn't matter. So if I kind of like put the 3x squared out in front instead, that would still be a correct answer. And then just remember, you can always check by foiling, and that's sometimes like a really good way to catch a simple mistake. Okay, so with the practice, I'll try to pause and try this one on your own. I'm going to go through this one a bit faster this time. So first we need to find a times c. So a is 6 and c is negative 6. So a times c is going to be negative 36. And then b is 5. Oops, not 8. I don't know why I wrote that. But b is 5. So I need numbers that multiply to negative 36 and add up to 5. So multiply to negative 36, I can do 9 and 4, and then if they're multiplying to a negative 36, one of these numbers needs to be negative. So I'll do negative 9. So that combination works. It multiplies to negative 36 and adds up to 5. So that's what I'm going to break down my 5x into. So every other part of the problem stays the same. So I'll do 6x squared. And then I'm going to do minus 9x plus 4x minus 6. And this order, if you did like plus 4x minus 9x, like you switched these, that would be fine. The problem would work out the same way. So now we're going to split our expression in half and factor out the greatest common factor from each half. So for the 6x squared minus 9x, I can divide both 6 and 9 by 3. And then I can also pull an x out of both. So when I divide that 3x out of my 6x squared, it leaves me with 2x. And then when I divide that 3x out of my negative 9x, it leaves me with minus 3. And then now we repeat that process with the second half. So for the 4x minus 6, the biggest number that divides into 4 and 6 is 2. So I'm going to do plus 2. And then I'm going to divide that out of each of them. So I would do 4x divided by 2, which is 2x. And then I would have to do minus 6 divided by 2, which is minus 3. And then I ended up with the same exact thing inside parentheses. That has to happen. So if that didn't happen, there's probably some issue somewhere that you want to go back and check for. So I'm going to pull that 2x minus 3 out of each term, which again, this is one term, and then this is another term. And then what I'm going to be left with when I take those out is my second factor. So I'm going to be left with a 3x and a plus 2. That'll go in parentheses. Okay, so feel free to rewind if you need to. Definitely stop by office hours if you're not quite remembering factoring. I'm happy to help. Okay, so the next section is kind of like combining different factoring, I guess, processes. So make sure that you're always checking for the greatest common factor first in any problem. The problems that we've done so far didn't have a greatest common factor that we can pull out, but now they will. Just kind of depends on the problem. So I'm going to zoom in here. So greatest common factor is something that you can like divide each term by. So in this case, 3 and 75 are both divisible by 3, so they have a common factor. So I'm going to pull the 3 out. And then when I divide that 3 out of both terms, like from the 3x squared, it would leave me with just x squared. And then from the minus 75, it's going to leave me with minus 25. And then now I have these two terms here. I have like two perfect squares that are being subtracted. Remember, 25 is just 5 squared. So now it's going way back up here to our like difference of squares section. Okay, and we even have like this same thing right here. So we can just kind of use that as our guide. So in this case, it's x squared minus 5 squared, so my a would be x, my b would be 5. I have to leave this 3 out in front, it can't just disappear. And then from there, difference of squares, the pattern is a squared minus b squared. So it factors into a plus b times a minus b. So it becomes x plus 5 times x minus 5. Oops. So 3 times x plus 5 times x minus 5. Okay, and then the next one over here on the right, so it's 2x squared minus 28x plus 98. So all these numbers, 2, 28, and 98, are all divisible by 2, so they have a greatest common factor as well. So I'm going to pull that out. It's just like kind of undistributing it from the problem. So when I take that out of the 2x squared, it leaves me with x squared. When I take it out of the 28x or the minus 28x, it would leave me with negative 14x because we would do negative 28x divided by 2. And then if I take the 98 and divide the 2 out, it would leave me with 49. And then now I have a trinomial, like 1, 2, 3 terms. So if this is the case, it goes back to, we have to see what a is, which for this problem, a is 1, b is negative 14, c is 49. So when a is 1, I just need numbers that multiply to c and add up to b. So that's going back to like this section right here if you want to look back at examples of that. Okay, so C is 49, and then B is negative 14. So I need numbers that multiply to 49, add up to negative 14. So for multiplying to 49, I can do 7 and 7. And then if they're multiplying to a positive 49, they have to both be the same sign, so either both positive or both negative. So since they're adding up to negative 14, I would make them both negative. So negative 7 times negative 7 is positive 49, but negative 7 plus 7, negative 7 is negative 14. So then I have to leave my 2 out in front. I can set up my parentheses. Since A is 1, I just put a 1x and a 1x right there. And then my two numbers that kind of made the combination work go in the other spots in the parentheses. So minus 7, minus 7. And then when you end up with the same factor like that, you can kind of shorten it a little. You can write it as 2. And then the x minus 7 part, you can condense, since they're the same factor, you can condense it into x minus 7 squared. And this is actually like a special type of, I guess, factoring. It's called a perfect square trinomial. And you should see that pop up in the workbook as well. It factors this way, but technically this is the perfect square trinomial. It's what factors into that like cool kind of squared looking final answer. Okay, so it looks like we just have a couple more problems. So this next part says using factors to solve a quadratic equation. So we factored, now we just kind of need to go one step further. So just kind of a reminder, in order to like solve by factoring, you need the equation to be in standard form with everything equal to 0, so everything's on one side of the equal sign. So if we're trying to get this equation right here to look like that, we would have to subtract over our 6 first. So we do minus 6 minus 6. And then everything else we just kind of copy down. So 15x squared minus 27x, and then minus 6 equals 0. I'm going to go ahead and zoom in here. So when you have, I guess, an expression when there's no equal sign, if you have a greatest common factor like we did up here between 3 and 75, there's a greatest common factor of 3. When you have an expression, it has to stay in front like that. But when you have an equation, you can technically divide out the greatest common factor because, an equation is like a scale. So if you divide a number by both sides, it doesn't change the overall value. Versus like an expression, if I were to make this 3 disappear, that would absolutely change the value of the expression. But an equation, as long as we do it to both sides, we're good. So if I look at like 15, 27, and 6, I know those are all divisible by 3. So I'm going to go ahead and divide out a 3. And it just gives me like smaller, easier numbers to work with. You always want to check for greatest common factor first. So if I do 15x squared divided by 3, that's 5x squared. And then negative 27x divided by 3 is negative 9x. Negative 6 divided by 3 is negative 2. And then now I have 3 terms. I need to try to factor it. So my A is 5, my B is negative 9, my C is negative 2. So when A is not 1, remember that's like the little bit more complicated version of factoring, but it's okay. So we have to take A times C, which is 5 times negative 2 is negative 10. And then B is negative 9. So I need numbers that multiply to negative 10, but add up to negative 9. So for multiplying to negative 10, I can do 1 and 10, and then I just need to make one of them negative. So to make them add up to negative 9, I would make the 10 negative. So that combination works. So I'll use 1 and negative 10. But remember, like when A is not 1, we don't go to the parentheses next. We actually have to kind of break down the problem a little bit more. So I'm going to bring this up here to give myself more space. So we copy down the first term, it's 5x squared. And then this middle term, the negative 9x, is actually what we kind of break down, and it turns into those two numbers that we found that worked for a combination. So negative 9x, I'm going to change into a 1x, so just plus x, and then a minus 10x. And it doesn't matter which one you put first, and then minus 2 equals 0. And then now I have to cut this, just this left side of my equation in half. I don't have to worry about the 0. And factor the GCF out of each. So from the left side, it's 5x squared plus x. So I can only factor out an x. And when I pull that out, it would leave me with 5x plus 1, because x divided by x would become 1. And then for my other side, negative 10x minus 2, I would have to factor out a negative, and because the first number is negative, and a 2 would be my GCF. So I'm going to do minus 2. And when I divide the negative 2 from negative 10x, that becomes positive 5x. And when I divide negative 2 from negative 2, that becomes positive 1. And then equals 0. These two are the same, which has to happen. If it doesn't, there's a mistake. So it becomes 5x plus 2, or it's not factorable. If there's no mistake, that just means it's not factorable, but I'm not sure you'll see problems like that. And then the remaining two pieces go inside parentheses, so the x minus 2 goes in its own parentheses, equals 0. And then now we set each factor equal to 0. So this is one factor. This is another factor. They each equal 0 in their own equation. So 5x plus 1 equals 0, and x minus 2 equals 0. And then we solve each separately. So for the 5x plus 1, I'd have to subtract the 1 over. So I would get 5x equals negative 1. And then I would have to divide both sides by 5 to get the x by itself. So I'd end up with x equals negative 1/5 as one of my solutions. And then for the second equation, I would have to add 2 to both sides. So I'd end up with x plus 2. X equals 2 for my second solution. So x equals negative 1/5 and x equals 2. And then the last problem, using the factors to find the zeros of a quadratic equation. So it's actually like the same exact type of problem as the previous one. It just has a different terminology. So instead of starting with an equation, we're starting with a function. Like you can see, it says f of x. But finding the zeros just means that you need to replace f of x with 0. So there's a note of that here on the right side. So we replace f of x with 0, and then we factor using any of the methods that we discussed earlier, depending on the problem. So basically, instead of this f of x, I'm going to put a 0 right here and rewrite the problem. And then now it's just like any other regular equation. So the zeros of a function is kind of like an interchangeable word for solutions a little bit. It's just basically the value of x that makes the function equal 0. So that's why we set the function x squared minus 25 equal to 0 to find the x that makes it work, because we know like the equal sign makes it balance. And then now I can go ahead and factor this. This is a difference of squares, so x squared minus 5 squared. And then I can use that pattern. So my a would be x, my b would be 5. So this would become 0 equals x plus 5 times x minus 5. And then now it's fully factored, so I can set each factor equal to 0. So one of them would be x plus 5. One of them would be x minus 5. So x plus 5 equals 0. X minus 5 equals 0, and then I just have to solve each. So for the first one, I would subtract the 5 over, get x equals negative 5, and then for the second one, I would add the 5 over and get x equals positive 5. So x equals negative 5 and x equals positive 5.